3.1. Why operability matters. Imagine a team that has just released a new feature. Spirits are high. The demo went smoothly, tests looked good, and the first users start using it almost immediately. For a while, everything feels calm. Then slowly, small signals begin to appear. A message from support. Another one from a customer. Someone mentions that the system feels slower than usual. A few requests begin to time out. Traffic continues to grow, and the feeling of control quietly begins to fade. The team jumps on a call. Everyone is looking at the same system, yet nobody really understands what it is doing. Dashboards show charts that move, but don't explain much. Logs exist, but they are noisy, incomplete, and difficult to connect to what users are experiencing. Someone tries to reproduce the issue locally, but nothing happens. So the guessing starts. Maybe the database is overloaded. Maybe the new feature introduced a hidden bug. Maybe the network is the problem this time? Minutes turn into hours. Tension rises. Decisions become emotional instead of rational. And somewhere in the background, a simple realization appears. We built this system, but we don't truly see how it behaves when things stop being perfect. That is the real entry point to the idea of operability. Operability is not about owning the most expensive monitoring platform or the latest shiny tool. It is about something much more basic. When things go wrong, and they always will, does the system help us understand what is happening, or does it leave us in silence? Because real systems live in the real world. A service crashes unexpectedly. A third-party dependency becomes slow. A bug passes all tests and reaches production. Usage grows faster than anticipated. None of those situations are exotic. They are normal, and they don't wait for our schedule. Now imagine the same team, in the same situation, but in a system built with operability in mind. The incident still happens, but the experience is different. Instead of confusion, there are clear signals. Metrics show where the pressure is increasing. Logs tell a story of what happened before the failure. Traces connect the journey of a single request across multiple services and reveal where it stalled. The team may still need time to fix the issue, but they are working with understanding instead of uncertainty, and that changes the psychology of the team. Without operability, teams become cautious and slow. Deployments feel risky. Every change feels like a gamble. People start blaming each other because they cannot see the real causes. With operability, the same team becomes calmer and more confident. They move faster, not because they are careless, but because they trust that problems will be visible and that recovery is possible. So when we say that operability is a goal, not a tool, this is what lives behind that sentence. It is not about graphs for the sake of graphs or alerts for the sake of alerts. It is about building systems that remain understandable, usable, and fixable when life stops being ideal. And life in production always stops being ideal sooner or later. Everything else we discuss in this chapter, monitoring, logging, tracing, metrics, reliability, scaling, exists for one purpose: to make those difficult moments less chaotic, and to give the team a sense of control instead of helplessness. A system that can explain itself is a system you can trust. And in the end, that trust is what operability really gives you. End of 3.1.